So, 4-diode full wave rectifier circuit. Note 7. Can you write at the top where it says note 7 the word bridge? Bridge. Write the word bridge right at the top where it says full wave 4-diode rectifier circuit. So whenever you come across the word bridge rectifier circuit, it doesn't need to be described anymore. It's understood that a bridge rectifier circuit is a 4-diode rectifier circuit. Okay? So that's a given. So we're going to look at the theory of the bridge rectifier circuit, but let's start off by drawing a bridge rectifier circuit. On the test, I will 100% guarantee ask you to draw a half-wave rectifier circuit, 1-diode, a full-wave 2-diode rectifier circuit. You will need to know how to draw those, okay? The 2-diode rectifier circuit needs a special kind of a transformer. What is it? Center tap. Okay? So the 2-diode rectifier circuit needs a center tap transformer. The 1-diode and the 4 diodes do not need a center tap transformer. So let's start out by drawing a transformer for my note 7. Here's the transformer. Two windings. Yes. 50 minutes. If you come early, you get 55 minutes. If you come even early, you get 60 minutes. Primary. No, what is it? Secondary. Okay, so because we're going to draw 4 diodes, there is a special way of drawing these 4 diodes, which is what I'm going to show you now. Okay, we start off with a diamond, and we connect the diamond at the secondary. So let's draw a diamond like this at the 2 ends of my secondary. Please go. Yep, same idea. Same idea. So, after drawing the diamond, what we want to do is this. This is AC voltage. This is AC voltage. So I'm going to write AC and AC at the top, because that's my secondary of the transformer. It's still AC voltage at that point. Everybody see that? And what's the aim of a rectifier circuit? Convert AC to DC. So what I now do is at the other 2 ends of my diamond, I write DC and DC. Okay? So those are my 4 corners of the diamond. AC at the top and bottom, DC at the other 2 ends. And I'm going to indicate this one here with a plus and the other end with a minus. Everybody do this. Everybody draw this. Okay? Now, because we're converting from AC to DC, I keep that in mind and I show my first diamond from AC to DC, so the arrow of the diode is going to point from AC to DC. You see that? Is the diode pointing from AC to DC? Because that's what I want to do. On the second side, on the lower side, same idea. I'm converting from AC to DC, so I show on this line the diode again with the arrow pointing from AC to DC. You see that? I'm trying to show you a way of memorizing this so that next class you will know, next year you'll know, 10 years from now you'll know exactly how to draw a bridge rectifier circuit. The other two sides, you just copy the way the diodes were shown on the other side. So when I go on to the other side of this diode, I show it the same way. And what about the fourth line? Same as the one on the other side. So I show the diode in the same direction. Okay, so that's the diamond. Those are the 4 diodes. And then I show, I've converted AC to DC. I'm going to use that DC voltage to operate a load. That load could be a cell phone, it could be a resistor, it could be a light, it could be a relay, it could be a motor, anything that needs DC, that's the load. So it connects between the plus and the minus. Load. You see that? So that is a bridge rectifier circuit. Go to page 11, appendix 3. Page 11, appendix 3, you see that what I just did was draw the circuit that is shown at the top of page 11. That is the bridge rectifier circuit. Okay? Now, let's go through the theory of how it's going to work. I have 2 cases. Case 1 is when I have my positive half of the sine wave. So this is case 1. Case 2 is for the negative half of the sine wave. So this is case 2. Let's look at case 1 first.